Hello everyone. In this video lesson, we are going to talk about value stream mapping. At the end of this topic, you should be able to recognize the VA, NVA, and NNVA steps in a process, determine NVAs that warrants elimination, and lastly, generate reports on the improvement in terms of cycle time, distance, cost, and efficiency. So let's start with the definition of a value stream map, or commonly known as VSM. VSM is a time sequenced map of all activities involved in the value stream. So this represents the entire process flow from start to finish. VSM serves as a blueprint for us to understand the current process in order to improve it by identifying waste and eliminating or reducing them. So this is a tool that is used by teams in order to improve processes. Here are some examples of VSM templates. So the first image is the process of business loan approval. And the second image, so this involves designing a public infrastructure for PWDs. So in engineering, we have our own VSM template as shown in the slide. So number one, we have here column for the task description. So here we are going to list down all the process steps or activities in our process. We have the duration or time, the distance traveled by goods or traveled by people in every step of our process. We have the classification or categorization of the process steps. It can be an operation, an inspection, a transport, a storage, or a delay. We have also the value classification if that step is VA, NNVA, or NVA. So how do we fill up this VSM template? So let's look at the process. But before that, so here are again the key elements that we are going to consider when we do our VSM. So number one, all actions and steps that take place during the creation of a product or service should be mapped in sequence. So yun yung ilalagay natin dito sa task description. Time information. So we need to include the cycle time, the lead time, and the waiting time in order to show the total time for each step and the overall process. So later on, we are going to fill up this column with time values, and then we are going to get the total cycle time or lead time. Material and information flow. So in your VSM, you should be able to track the flow of materials and information between steps to identify where delays occur or bottlenecks. And lastly, it's also important to distinguish steps as either VA or NN, VA or NVA. So here is a summary of what we are going to do in order to accomplish a VSM. So number one, we are going to still do process mapping. So after mapping the entire process from start to finish, we are going to define the process category of each step. So here are the symbols that are important to us in the VSM. So inspection, operation, transport, delay, or storage. So as you can see, we have here no decision symbol. So we only include the 5 other symbols. After defining the process category, so we are going to classify the activity as VA, NVA, or NNVA. And then if we have identified an activity as NVA, so we are going to decide what will be our action for that step. So are we going to eliminate it? Are we going to reduce it? Or use the concept of concurrency or parallel operations? And then lastly, we are going to report on an action plan to see what improved in the current process and what is our recommendation so that we can improve further the efficiency of the process and the cycle time. So how to construct a VSM? Step 1 is to plot the details in the task description into the VSM template. So our tip here is to gather details about each task or steps involved in the process and include the time, the materials, and resources used or needed in order to achieve that step. So that's the first step in constructing your VSM. Step 2 is to determine the process category of each activity as operation, inspection, transportation, storage, or delay. So that's why our first lesson on process mapping is very important. You should be able to distinguish between what an operation is versus what an inspection is, transportation, storage, and delay. So you're just going to check the boxes here. Number 3, identify the category of each activity as VA, NVA, or NNVA. So again, let's review. If we have a value-adding activity, these are activities that directly contribute to customer value. NVA, this adds no value and creates waste. And NVA, so these are necessary for compliance or operation, but similar to NVA, does not add direct value to customer. And number 4, decide on which NVAs can be eliminated or reduced. So when you have decided that that NVA should be eliminated or reduced, so you put that into the notes column. Example, so if you have identified a delay or waiting type of waste, so you can either reduce that waiting time, and your recommendation would be to optimize scheduling or eliminate excess transportation. So those are some examples. And 5, report on the action plan and the degree of waste eliminated in terms of time or distance if applicable. So in the first part, after filling up all the time or duration of each step, so you should be able to compute for the total cycle time. And then after removing the waste, so you can get another cycle time, which is much shorter than the original cycle time. So ibig sabihin nun, when you do process value analysis and when we use this VSM, so makikita natin dito how much time, how much distance or transportation distance is reduced, no? So at the same time later on, makikita natin dito yung pagbabago in terms of what we call the process cycle efficiency or PCE. So let's have this example for us to better understand how to fill up the VSM template. So here I have identified a certain process, which is the process of watering your garden plants, sa mga plantito at plantita. So I have listed 7 steps. First step, get water container with sprinkler end from your storage room. Step 2, go to the water faucet. Step 3, turn on the faucet to full flow. Step 4, fill the water container to the brim. Step 5, turn off the faucet. Step 6, go to your garden or the plant location. And then step 7, you water the plants. Okay, so the first step for us to fill up our VSM is of course to again fill up column 1. So I have just listed the 7 steps in my first column or the task description. And then for the column to the left, so I have just labeled the activities as A1, A2, A3, and so on respectively. And I have determined here the duration for each activity in terms of seconds, no? And I have also listed here the distance in meters kung meron mang transportation na nangyayari doon sa step na yon. So for example, in A1, activity 1, wala namang distance na na-record. Okay? So, yung pagpunta sa faucet from the storage room, so doon ko ni-record yung transportation distance which is 10 meters. So, this is just for illustration purposes. No? And then after doing that, so let's try to categorize the process activities and in terms of its value also. So for A1, which is getting the water container from your storage room, so it is an operation activity and it is NVA. Bakit siya NVA? Because that activity itself does not add value to the whole process. So ang kailangan mo lang dito in order to achieve your result, which is to water your garden plants, kailangan mo lang dito ay, of course, yung plants mismo, dapat present. And of course, meron kang tubig, source of water. Okay? A2, you go to the water faucet. So that is a transport activity kasi merong movement. So movement of the water container and at the same time, movement of the person who will water the plant. So any form of transport in a process is considered NVA. However, meron siyang sinabi dito. In this case, the faucet is the source. Kung saan ka pupunta, yun yung kailangan mo kasi, yung faucet. Therefore, yung pagpunta doon ay considered as NNVA. So, necessary siya, but then again, it does not add value to the customer or to the whole process itself. A3 is turn on the faucet to full flow. So, it is an operation, yung pag-turn off or on ng faucet. And it is a value-adding activity. Kasi kung hindi mo ginawa ito, wala kang access sa tubig. A4, fill the water container to the brim. This is a storage because you are filling up something, no? And storage is some form of a controlled delay. So delay causes queuing and create waste. Therefore, it is NVA. Kasi especially kung medyo malaki yung container, so maghihintay ka ng medyo matagal para mapuno yung malaking container na yon. So that's the simple explanation for A4. A5, turn off the faucet. So it is an operation similar with A3, but this time it is an NNVA. Okay, because it does not add again to the value of watering your plants, but it is necessary para hindi ka gumasto ng napakaraming tubig. Sayang sa babayaran mong water bill later on. A6, go to plant location. So again, this is a form of transportation activity kasi merong movement, no? So it is considered as NVA. And lastly, water the plants, A7, that is operation and it is value-adding activity. Kasi kung hindi mo to ginawa, what's the purpose of doing the entire process? Okay, so we have identified the category and classification of A1 to A7 based on the process map symbol and based on value classification. Okay, so for our current process analysis, the total time used for the manual watering process, it took us approximately 173 seconds. And in terms of the distance covered, we covered 25 meters of movement. And from our activities, we have classified A1, A4, and A6 to be our NVA or the non-value adding activities. So next step, ang goal natin is to decide kung ano yung gagawin natin dito sa A1, dito sa A4, and dito sa A6. So here are some waste reduction suggestions. So for A1, instead of getting a container with sprinkler end, why not get a hose instead? Kasi kung meron kang hose, hindi mo na gagawin yung A4 kasi nga wala ka ng container. So hindi mo na kailangang maghintay para mapuno pa yung container na yon. So that's one way to reduce A1. To reduce A4, so kung wala kang hose, ang meron ka lang ay water container, so to reduce the controlled delay caused by filling the container to the brim, so only carry as much water as is required to avoid overproduction. Kasi nga, kung finil mo yan into the brim, hindi mo naman pala kailangan lahat ng tubig na yon, edi nag-aaksaya ka ng resources. Okay, so that is overproduction. And lastly, A6. So instead of going to the plant location, carrying the water container filled to the brim, so kung medyo malawak yung garden na iwawater mo, then baka pabalik-balik ka niyan kung hindi sasapat yung water container mo, no? So, in order to reduce this waste, so you may use multiple containers or use a large container to reduce the trips. So, ang iiwasan dapat natin for A6 ay yung pabalik-balik sa ating water faucet. So these are some ways to reduce the said activities which are considered as waste. So again, you fill up the notes column, eliminate, eliminate, modify, or eliminate. Okay, so by eliminating or reducing the NVAs A4, A6, and A1, the time and distance required for watering is significantly reduced. So in the improved process, so the time is reduced to 60 seconds. So naging 1 minute na lang instead of the previous na 173 seconds. And the total distance is reduced from 25 meters originally, naging 10 meters na lang. Ang tinanggal dito ay itong distance covered when you do A6. So ultimately, here is the proposed solution to improve the process. So an eventual solution to fully optimize the watering process is to implement a sprinkler system. So this system can, number one, automate the watering process by eliminating manual effort entirely. So hindi mo na kailangan magpunta sa storage room, kunin yung container, i-turn yung faucet, hintayin mapuno, etc. etc. Okay, so this will further reduce the time and movement. No need for manual filling, no need for carrying or transporting water kasi naka-automated ka na. Optimize water usage. The sprinklers can be programmed to use the exact amount of water required. So this is for more advanced sprinkler systems siguro. Okay? So let's talk about the cycle time or the lead time. Kasi kanina ko pa 'to binabanggit. So let's define. Lead time is the total time required to produce one item or to complete one cycle of a process. Now, lead time comprises of two components. You have the value add time and the non-value add time. So obviously, the value add time represents the total time spent on value adding activities. And the non-value add time represents the total time spent on waiting, spent on delays, or other activities that are considered waste. Okay? So here, in our VSM template, so our non-value add time are the following. Itong 5, itong 60, at saka 48. So if you total that, you can get the non-value add time. And for the rest, these are considered value add time. So kailangan mo silang i-add. So get the sum of the VA time and NVA time, you get the lead time. Then how to compute for the efficiency or the process cycle efficiency. So PCE is also known as the value added ratio. It is the metric used to measure the proportion of value added time within the total process. So PCE is value add time divided by the lead time, wherein the lead time is the sum of value add plus non-value add time. So this is in terms of a percentage. So the higher the percentage, the more efficient the process is. So for example, here is a process map of a certain process wherein the value add time totals to 182 seconds and the non-value add time is 678 seconds. So therefore, by adding these two, we get the lead time of 860 seconds. So to calculate the PCE, you get the value add time, 182, divide that to the lead time, which is 860, 182 divided by 860, that is 0.21 or 21%. So what does this 21% mean? Only 21% of the process is considered value added to the customer. So the rest ay waste na. But in reality, or in most real-world processes, the PCE is typically very low, often in the range of 5% to 10%. So according to George, um, for example, in fabrication, the typical PCE is 10% only. For assembly, that is 15%. For casual business or transactional businesses, 10% lang din. So this means that in many cases, only a small portion of the total process time is really spent on value-adding activities. Majority of the time is consumed by NVA activities. Kaya nga palagi nating sinasabi kapag we undergo a certain process, hindi maiiwasan yung magkakaroon ng delays, magkakaroon ng bottlenecks. But the good thing is, meron tayong lean methods. Once lean methods are applied, PCEs can be improved. Lean methods, again, focuses on reducing NVA activities and streamlining workflows to maximize value-added time. So after applying lean methods, according to George, we can increase the PCE to 20 to 25% or higher. So if these are your typical efficiencies in column 2, then in column 3, you have your world-class efficiencies. So you can get as high as to 80% in the manufacturing industry. So here is another example for you to practice filling up your VSM template. So that ends our lesson. Thank you for watching.